All right, well, hello there, sixth graders. We are now diving into chapter 7 here for this year. And today our focus is on finding the area of a parallelogram. Now, if you're not sure what a parallelogram is, a parallelogram is essentially a type of quadrilateral that has two sets of parallel sides. So if you look at this figure here, the top and the bottom are parallel. The left and the right are parallel. This line here in the middle is just a signal from the height from the top or from the bottom to the top straight. So you'll notice this is not a true height. This measurement right here, the 16 meters, that's the true height from top to bottom. Because the formula to find the area of a parallelogram is area equals the length of the base times the height. When I talk about area, I'm talking about how much space it covers. You can equate area to like carpet. If you're laying carpet in your bedroom or somewhere in your house, or we got new carpet in the classrooms this year. The people who install the carpet had to do measurements, had to find the area of the floor, the area of the classroom, to know how much carpet to cover the floor. So that kind of lets you know what area is, how much, essentially you can think how much carpet would it take to cover this. Now, for the area of a parallelogram, it's base times height. So it's the length of the base, in this case it's 13 times 16. So if I want to find the area, I'm essentially going to come up here and I'm going to do 13 times 16. This isn't hard to do. 6 times 3 is 18. Put the 8 down, carry the 1. 6 times 1 is 6, plus 1 is 7. Put the 0 down. 1 times 3 is 3. 1 times 1 is 1. I add these together. 8 and 0 is 8. 7 and 3 is 10. Put the 0 down, carry the 1. 1 plus 1 is 2. I get 208. When we do area, it's always in square units. So we make it look like a little exponent 2. The idea being that if the floor were this size, you could cover it with 208 squares of carpet, all 1 square unit, meaning that the square 1 meter, 1 meter, 1 meter, 1 meter, because a square, all 4 sides are the same. 208 pieces of carpet that size will cover this floor. All right, now here's one that looks a little bit different. It almost looks like a three-dimensional figure, almost like a triangular prism. But what we're showing here is they put this height measurement outside. The idea that this length from bottom to top going straight is this unit right here, 9 1/3 feet. And they're just kind of shading it to show that. So when you see this shading, it's not actually part of the parallelogram. It's just saying, hey, this is giving you a height measurement. So if I'm doing base times height, this is going to be 7 times 9 1/3. So I'm going to be doing 7 times 9 1/3. Well, everything's going to have to become a fraction, because now as sixth graders, they're going to incorporate decimals, fractions, all that stuff, because we've reviewed that. So we want to kind of touch on that in this video as well. Everything's going to become a fraction. 7 as a fraction is going to be 7 over 1. When I turn 9 1/3 into a fraction, 3 times 9 is 27, plus 1 is 28. So it's going to become 28 over 3. 3 times 9 is 27, plus 1 is 28, so 28 over 3, denominator stays the same. I can't make the 1 in the 28 any lower. Nothing besides 1 goes into 3 and 7. Well, I know that 1 times 3 is 3. If I come over here and do 28 times 7, and I take care of that, 7 times 8 is 56. Put the 6 down, carry the 5. 7 times 2 is 14, plus the 5 is 19. I get 196. So I come over here. 7 times 28 is 196. Well, if I'm going to do 196 divided by 3, I'm taking 3 going into 196. Well, 3 cannot go into 1, but I think it can go into 19 6 times. 6 times 3 is 18. 19 minus 18 is 1. Drop the 6. 3 can go into 16 5 times. 5 times 3 is 15. 16 minus 15 is 1. I have 1 left over, so I find that 3 can go into 196 65 times. There is 1 left over. My denominator 3 is going to stay my denominator 3. That is in simplest form. No number besides 1 can go into both 1 and 3. And we're in square units. So I have feet. So this is going to be feet squared. If I have squares of carpet, each 1 foot on every side, I can fit 65 1/3 of them inside this parallelogram. All right, moving right along. A lot of the problems you get are simply just going to give you the measurements, base times height. Well, on this one, the base is 2.92 inches and the height is 3.7 inches. So I'm going to come back. I apologize. I'm going to go ahead and come back to this board here. It's going to be 2.92 times 3.7. So I'm going to come over here and do 2 92 hundredths times 3 7/10. Remember, in multiplication of decimals, my decimals do not have to be lined up. I just have to remember the decimal rule at the end. 7 times 2 is 14. Put the 4 down, carry the 1. 7 times 9 is 63. Plus 1 is 64. Put the 4 down, carry the 6. 7 times 2 is 14. Plus 6 is 20. Put a 0 down, so it's all lined up with my 3. 3 times 2 is 6. 3 times 9 is 27. Put the 7 down, carry the 2. 3 times 2 is 6. Plus 2 is 8. Now I'm going to go ahead and add these. 4 plus 0 is 4. 4 plus 6 is 10. Put the 0 down, carry the 1. 1 plus 0 plus 7 is 8. 2 plus 8 is 10. There are 1, 2, 3 numbers that come after the decimal in the problem. So 1, 2, 3 numbers that come after the decimal in the answer. 10 and 804 thousandths. And since I was using inches in that problem, this is going to be inches squared. If I had squares of carpet that were 1 inch on every side, not very big, I could fit 10 and 804 thousandths of them inside that particular parallelogram. All right, moving right along. Here's another example of a parallelogram. Now here they've got 3 measurements. Now that's interesting because we don't want to forget the formula that is just area equals the length of the base times the length of the height. And as you know, 2 variables right next together mean multiplication. So we just kind of write in short, A equals BH. Well, so that's the joy of math, folks, is they give us some information, but we have to determine what information is relevant. Well, if I look here, the length of the base, it looks like, is 14.3. So this number seems relevant. The height is the distance from the bottom to the top, just a straight distance. Well, that looks like it's the 22 from here, from bottom to top. This 25, it's nice to know, but this 25 really does not help us find the area of the parallelogram. So it's important to know what information you need, what measurements you need. So for this particular one, it's going to be the 14 3/10 times 22. So here we go. 2 times 3 is 6. 2 times 4 is 8. 2 times 1 is 2. Put a 0 down so everything lines up with my 2. 2 times 3 is 6. 2 times 4 is 8. 2 times 1 is 2. When I add these together, 6 plus 0 is 6. 8 plus 6 is 14. Put the 4 down, carry the 1. 1 plus 2 is 3. Plus 8 is 11. Put the 1 down, carry the 1. 1 plus 2 is 3. There is one digit that comes after the decimal in my problem, so I need one digit that comes after the decimal in my answer. My final answer, 314 and 6/10 square inches. I could fit, if I had squares of carpet that were 1 inch on every side, I could fit 314 and 6/10 of them inside that parallelogram. All right, this is my last one, and once again, they've given us 3 measurements, so we need to kind of figure out which measurements really help us. Well, it looks like my base is going to be this one over here. That's my straight side, okay? So my base is going to be 41 and 1/4, okay? That's going to be my base there. So, and then it looks like from, if this is my base, my top to bottom is going to be from here to here. Well, that looks like it's 23. That 34, it's nice to know that distance, but this does not help me find the area of this parallelogram. Area is just base times height. So this is going to be 41 and 1/4 times 23. Well, let's think. Now I've got to start doing some things here. This ought to be interesting. 4 times 41. Well, I know that 40 times 4 is 160. And then 1 times 4 is 4. So that tells me that 41 times 4 is 164. And sure enough, if I were to do that, 41 times 4, 4 times 1 is 4. 4 times 4 is 16. I get 164. Plus the 1 is 165. So that tells me that I've got 165 over 4 times 23 over 1. Well, I can't cross-check a 1 and 165. Nothing besides 1 will go into both 4 and 23. So I know that 4 times 1 is 4, but I'm going to have to figure out what 165 times 23 is. Well, so let's come up here. 165 times 23. Well, let's figure that out. 3 times 5 is 15. Put the 5 down, carry the 1. 3 times 6 is 18. Plus 1 is 19. Put the 9 down, carry the 1. 3 times 1 is 3. Plus 1 is 4. Put a 0 down so it all lines up with my 2. 2 times 5 is 10. Put the 0 down, carry the 1. 2 times 6 is 12. Plus the 1 is 13. Put the 3 down, carry the 1. 2 times 1 is 2. Plus the 1 is 3. When I add these all together, let's kind of get those out of the way. 5 and nothing is 5. 9 plus 0 is 9. 4 plus 3 is 7. Nothing and 3 is 3. So I end up with 3,795 over 4. Well, so I'm going to have to come over here, and I'm going to have to do, let's see where I get some room here. I don't get a lot of room here. So let's come over here. We'll try to, let's just kind of cross some of this off from an old problem here with my finger. All right, and let's go ahead and work with 3,795, all that being divided by 4. Well, 4 can't go into 3, but I do believe that 4 can go into 37 9 times, and that 9 times 4 is 36. 37 minus 36 is 1. I'm going to bring the 9 down. See, all these math skills that you've practiced throughout 5th grade and 6th grade, all are relevant here in Chapter 7 as we're doing area and volume. 4 can go into 19 4 times. 4 times 4 is 16. 19 minus 16 is 3. I'm going to go ahead and bring the 5 down. I believe that 4 can go into 35 8 times, and that 8 times 4 is 32, and that 35 minus 32 is 3. So I find that 4 can go into 3,795 948 times, and that there are 3 left over. My denominator is going to be 4. That is in simplest form. No number besides 1 can go into both 3 and 4. The measurement they gave us was meters. So this has to be meters squared. And if there was a room this size that we were putting carpet in, and we had 1 square meter carpet sizes, so squares of carpet, 1 meter on all 4 sides, we could get 948 3/4 carpets that size inside that parallelogram. All right, we'll talk to you later, 6th grade. Bye.